Hey, it's Dr. J. Check out my new toy I got today. So we've been talking about rational functions for the last week, and I thought I would use this Learning Glass software and hardware to show you how to graph the function f of x equals -2 times the quantity x plus 1, x minus 3 over x plus 2, x minus 4. We've already gone over all the details. Let me just summarize all the details. So you remember the domain? Remember the domain rule? What's the domain rule? You look at the denominator. That's pretty easy to remember. Domain, denominator. And you set the denominator not equal to 0. So we have two factors. So we got x plus 2. We got x minus 4. We're going to set them not equal to 0. This is the college level algebra class, so I'm going to hope that you can do this in your head. X is not equal to -2. X is not equal to 4. All right, so that's our domain. We have a couple different ways to write this. We can write it with the fancy set braces. That's what I call the fancy pants. Or you can write it like this: -infinity to -2, union -2 to 4, union 4 to infinity. All right, so that's the domain. And you remember the BOGO, buy one, get one. Remember that? If you find the domain, you automatically get the vertical asymptotes, the VAs. You just remove the not equal to and you make it equal to. That's a buy one, get one deal. You solve the domain, you're going to get the asymptotes for free. Absolutely free. It's not a catch like those cell phone ads they always give you. The horizontal asymptote. Remember the horizontal asymptote, we're going to look at the leading coefficient. Yeah, the leading coefficient. Now, technically, there's an invisible 1 under here. So it's the ratio of -2 to 1. So it's y equals -2. Sometimes that comes out to be a fraction. And then remember, if it's not there at all, it's an invisible 1. So it would just be y equals 1. But that one's pretty obvious. It's -2 there. So we've got the vertical asymptotes. We've got the horizontal asymptote. We've got the domain. Anything else? Intercepts. Good, intercepts. I heard you. I heard you through the internet. The intercepts, for the y-intercept, we plug in 0 for x. So we're going to replace all these x's with 0. Do I have enough room over here? Yeah, I do. So I got -2, 0 plus 1, 0 minus 3, 0 plus 2, and 0 minus 4. It's a lot of writing, but it snaps out very quickly. You get -2 times 1 times -3 over 2 times -4. So it's -3/4. The numerator becomes 6. The denominator becomes -8, so it's -3/4. Now remember, I want you to write that as an ordered pair. The most common mistake is putting the 0 in the wrong spot. Remember, we plugged in 0. So 0 goes in the x. And then this is your y. I can't tell you how many times I've seen people solve it correctly and then write it backwards and get it wrong. So there's your y-intercept. The x-intercepts, you're going to set the numerator equal to 0. So x plus 1, only the parts that have x, because they're x-intercepts. And then x minus 3 equals 0. Again, this is the college level version of this course, so I think you can all do that in your head. X is equal to -1, x is equal to 3. Pretty much running out of room here, but let's see if I can squeeze my answers in right here. -1 is the x, and the y value is 0. 3 is your x, and the y value is 0. All right, let's box everything that we're going to keep. So we want those intercepts. We want these asymptotes. And we don't need the rest of this. You don't really use the domain when you're drawing the graph. The domain is just an implied restriction on the values. So it basically tells you what values x can take. I'm going to erase the original problem. You already probably have it written down. So let's do some color. Let's try some colors. What we got Maybe not that color. I got a pink pen here we'll use in a second here. So that's our y-axis. There's our x-axis. It'd be cool if there was a button I could press that would turn this into a grid or something. That's probably in Gen 2. So what should we plot first? The asymptotes typically. So -2. I got my pink pen. So an asymptote is a vertical line or a horizontal line that cannot be crossed. So +4. It's a do not touch. That's what that literally means. Don't touch me. And then we have a horizontal asymptote at -2. And this forms sort of like a grid or a sort of a boundary of where the graph is going to be. And then we'll plot our x-intercepts. So we've got one at -1, and another one at 3. And then our y-intercept is -3/4. So it's right about there. If you're drawing this with a mouse, as long as you click between -1 and 0, it's close enough. My dad used to say, good enough for a government job. It does have to be in the right region. So that's part of your graph. And then we have what are called the wings, okay? And we mentioned this in lecture. If the center piece is a U shape, then the wings are always opposite. So the wings would never be right next to the other piece of the graph. They'd always be in the opposite regions. They are symmetric with respect to each other, so they look like this. The other version of this similar problem, maybe I'll do in a part 2 follow-up, is if this has more of an S shape, if the center has an S shape, then the wings are diagonal from each other. And so there's a very noticeable pattern if you've done a couple of these problems before. Unfortunately, the graphing software that's on Canvas is not this sophisticated, so it's multiple choice. So you draw this in your notebook and then look at the 4 choices and pick the one that looks like this, and you should be just fine. Well, I hope you all enjoyed the first Learning Glass lecture from Dr. Jordan. Until we meet again, I'll see you on the internet.